Alright, this is second video on the engine. It's Sunday, April 2nd, and I'll just get straight to the point. Basically, on the left we have the numbers from 2003 profile. As you could see right here from the previous video, I underlined the most used cup engine right here in blue. As you can see, the pressure values are right here: 120, 231 and 202. Just made this little paint file to kind of organize and structure this a little better. Now what we're trying to do basically is convert these numbers to real life numbers. Then let me make them in green, we'll convert that to real life numbers, and then we'll take real life numbers from 1963 engine from a Camaro, a 283. We'll take those numbers and convert them into NASCAR 2003 format, thus making a 1967 engine. If only that would be so simple. Alright, now step number 2. Here I have a torque curve from the website right here, Automotive Catalog or automobilecatalog.com. Anyway, and the three values that I assume that we are dealing with are, let me point them out over here. Torque 1 at 0 RPM or approximately 0 is the initial torque. I assume what we're dealing with is this guy right here. Then at 7,000 RPM on the NASCAR profile, and of course definitely much lower on this one, is the maximum torque value right here. And then the torque at maximum horsepower. Got 195 horsepower at 4,800 RPM, and that would be somewhere around here. So we are dealing with these three values: torque 1, torque 2 and torque 3. That's my assumption as of right now. Alright, and in this segment I want to talk about 1967 283 torque 1, 2 and 3 values. My assumption is we're dealing with these points: initial torque, maximum brake torque, and then the torque that we're developing at the point where we're making max horsepower. Something like, as you can see right here, these are Newton per meters, 385, 285 and 150. When you convert those into regular foot-pounds of torque, it comes up to 110, 284 and about 210. So let me quickly redo them as they should be. So this is 110 foot-pounds. This is about 210 foot-pounds. That's the point at maximum horsepower. And maximum brake torque that we're making is 284. The engine is advertised at 285 right here, so we're spot on, plus minus 1. Actually this one should be 285, but that's fine. What else? Now we got our PSI values for the NASCAR 2003 profile, and we got our real life values for 1967. Assuming then these are BMEP or IMEP, either brake mean effective pressures or indicated mean effective pressures, which I'm not sure exactly. This is where my research is at the moment. Anyway, assuming that these are BMEP values, these guys, we can use a known formula that goes like this: torque times 150.8 divided by cylinder displacement. We can easily plug in the numbers, and our initial torque is 110 foot-pounds times 150.8 divided by 283. That is our engine size. Let me calculate that briefly in front of you. 110 times 150.8 divided by 283, it's about 58.6. 58.6. That's our general coolness or efficiency of our engine. So our first number we got right here. Let's keep plugging in the numbers. At maximum torque that we got is 285. It should be 285, not 284 once again. That's the engine advertised at. times 150.8 divided by 283. Once you remember these formulas, you can run them down so easily, and you get very fast okay, that one comes up to about 151 psi. That's the top pressures that we're making. The last value at max horsepower, 210 times 150.8 divided by 283. Let's run it one more time. 210 times 150.8 divided by 283. That one comes up to about 112. Let's just say 112. My previous calculations came up to 113, but that's fine. So we got our numbers right here. We got 58, just approximately, 151, and 112. These are the pressure values that you could compare to these guys. 120 versus 58, 231 versus 151, and 202 versus 112. That's 800 horsepower NASCAR engine versus a 200 horsepower little clanker from 1967, the smallest V8 that was available in the Camaro. Now the RPM that we are making, RPM 2, where we're making our max torque, is only 2400 RPM, and max horsepower is made at 4800 RPM. So here we got our basic numbers for our basic profile. If I'm out to input them instead of this guy, it would go like this: 58 at 24, 151, then the top horsepower is 4800, then the max torque at max horsepower 112. We are dealing with a 3-inch stroker, 283 V8 with one intake valve. We are running 172 the intake valves. That's what I looked up. And now comes the red line right here. Stock NASCAR red line is 9300 RPM. My trick that I'm gonna show you is I change the red line to, let's say, 30,000 RPM, or it doesn't really matter, 15, 30, 40,000. This will let the engine run as fast as it can possibly, and this step is necessary for me to show you what happens next. This would be our basic profile. You could also change oil and water cooling to 0, or you can run the NASCAR values. This is all done for testing. This is the end of the meat part of this video. Now I'll show you the profile that I made and how it behaves in game. Basically running these numbers. The numbers that I want to pinpoint is these guys right here, the 3 power numbers and the 2 RPM values. Now I want you to observe carefully what happens in game when I free the engine up to 30,000 RPM or whatever, where there is no rev limiter set. You will see what happens to this engine next. Alright, and in this segment I hope we have enough time to make few in-game test runs. Also I want to show you the physics editor blank right here. I copy pasted all the lines for all the engines and all the physics right here. For example, if you just want to change the NASCAR Cup physics right here, you would only copy paste these lines, and all of the other engines, if you would have liked to leave them stuck, you just delete the lines and you do not include them. Anyway, that is not so important. Here we have all the engines for all the physics. As you could see, torque 1, RPM 2, torque 2, RPM 3, and so on. We got engine stroke, cylinder displacement, V8 with one intake valve size, red line limiter, and this is like the rev limiter to cut the ignition or such and such, is set at 20,000, so we can free spin this engine as fast as it can possibly go. Peak power, if it is indeed peak power, I just set it at 195 following that theory. However, changing this value does not seem to change anything, and more testing on that later. Oil and cooling and water has also been set to 0 just to see how fast our engine will heat up with no cooling whatsoever. We're running a 4-gear transmission, and I'll stop right there. After we do all of our changes and save the file, we get this NR2003 test. Start that. This is our engine. Basically, in this edit we only changed the engine. We haven't changed any chassis or tire values, so our cars, because I am using CTS physics for now, are gonna look like this. They're still gonna look like a truck, but it's just gonna have a different 283 from 1967 engine in it. I want to keep it realistic, so I'm not gonna run the muscle car mod for the visuals. That's our goal, but for now our actual car is supposed to look like this, like a truck with an old engine. So here we go on the test session. Let's go on the pig's dragway. The track doesn't really matter because we're not gonna run any laps. And as you can see, the engine behaves normal and everything is fine in neutral. We're revving and everything seems okay. And here comes problem number 1. I want you all to remember this one. Our engine is capable of overcoming 8, 9, 10,000 RPM. Watch. It can rev as high as it possibly can, like it has a shot of nitrous or turbocharger or something. Like it does not care about volumetric efficiency or other factors. Watch this. Like we can literally rev it as high as it possibly can go. And that is an obvious no-no. Let me open a new paint file and we're gonna officially call this problem number 1. Too much revs. For now, I'm gonna stop the video right here and make a separate one to go from here on. Kinda base the theory and the strats from here. Yeah, this one is kinda technical and complicated, but it is what it is. I had to share this info first before I can go into my thought process and asking you questions and kinda getting feedback back and forth onto what's going on. For those of you that finished till the end, thanks a lot. I'm gonna try to make something happen soon. Stay tuned until then.